Welcome, Math 10C students, to our 5.7 lesson on interpreting graphs of linear functions. Now, I know that this is part of Chapter 5, but this will actually be going along with the outcomes, which are part of Chapter 6. So that's why you wrote the summative assessment for me on Chapter 5 that just included the concepts from 5.1 all the way to 5.6. 5.7 will be included on your Chapter 6 summative assessment. So this chapter is going to be looking at some more linear functions or linear relations. And in this specific lesson, we're going to be looking at x and y intercepts, as well as reviewing some information on domain, range, rate of change or slope of a line, okay, and a few other concepts. So before we get into this lesson, there's again just some important terms. So you can either write these terms down, or if you have these notes printed, you can highlight them as we go. So any graph of a line that is not vertical represents a function, okay? And that was on the previous lesson as well. So just as a quick little reminder, and I'm just going to put my sticky note here so I can have a little bit of room to write this down for you. So just a little bit of reminder of what a function is. Okay, from the last section, a function is something where each x value has only one y value. So let me show you an example of what I mean by that. I'll give you an example of something that is a function, meaning that the reverse of this would be a non-function. So if we had something like, we had some fruits, and then the colors of the fruits, we could have apples, oranges, and maybe tangerines. Okay, and then in the other circle of our arrow diagram, we could have something like the color of these said fruits. So orange and red, okay? So our apples are obviously red, and our oranges are orange, and our tangerines are orange as well. So this would be a function. If we reverse these, okay, so we had these as our x values, okay, we had these as our y values, and again, imagine that I'm physically reversing these, I'm flipping them around. In that case, in the red, we would have one arrow going to apples, but the orange would have two arrows, one going to oranges, one going to tangerines. So if we reverse that, that would be a non-function, okay? So just a reminder of what a function is, because I feel like some people struggled with that in the last section. Okay, so if we have a graph of a line that's not a vertical line, that we call a linear function, okay? Now we can use the intercept, so where the line of our graph crosses the x-axis and where the line of our graph crosses the y-axis to help us draw the graph of that, okay? So we can use the intercepts, okay, to describe the graph of a linear function. So if we take a look at this graph that's shown here in the example, it says this graph intersects the horizontal axes, which is our x-axis, at 2. And we can see right there from that point that yes, it does intersect at 2. So then we could say our horizontal intercept is 2. Sometimes instead of a horizontal intercept, it might also be called an x-intercept. So those terms can be used interchangeably. So either x-intercept or horizontal intercept. So if we look at the coordinates of that point, they are 2 and 0, because our y value would obviously be 0 at that point. Now the graph intersects the vertical axes in this picture right here at 5. That means our vertical intercept is 5, and the coordinate for that point are 0, 5. Now again, instead of being called a vertical intercept, sometimes it might also be called a y-intercept. Those are the same concept, okay? It means the exact same thing. So let's take a look at this example below. and figure out our horizontal and vertical intercepts, and then the domain and range of this graph. Okay, so if we take a look at this graph here, we can see from the graph that it is showing the temperature of some location over a 12-hour period of time. So it asks us to find the vertical and the horizontal intercepts and what do they represent. So let's look at each of them. I'm going to use V for vertical. Okay, so my vertical intercept, if we look here, right here, so look at the line. Where does the line cross the y-axis or touch the y-axis? So we can see here from this graph that it's crossing the y-axis, and again, each of these points is 2, so -2 is here, -4, oh, -6, okay? So it's -6, that is our y-intercept or our vertical intercept, and that is showing us our starting temperature. And our starting temperature is -6 degrees Celsius. Okay, so that's what we can find from our vertical intercept. Now they want to know what our horizontal intercept is. So where does the line cross the x-axis of the horizontal line? So if we look right here, oh, okay, the line is crossing at 4. So I'm going to use H for horizontal. Okay, what that's telling us is when the temperature reaches 0. So the time at which the temperature is at 0 degrees Celsius, and we can tell from this graph that time is 4 hours. Okay, so that's what we can tell from those two intercepts. The next thing that they've asked us to do is find the domain and range. So again, since we have a start and an end point here, but we have a line that's connected or continuous data, we can find the domain and the range of this data. So remember, we use those pretty looking brackets there. Okay, so if we look here, the smallest number on the x-axis that our number is at is 0. Okay, and there is a point there. So we're going to say that x is greater than or equal to 0. And if we look at the x-axis on this end, at its very highest point, it's at 12. And it could be equal to 12 because it has a point there. So x is less than or equal to 12. And again, we finish off with our beautiful brackets there. Now let's take a look at the range. Okay, so our range for y, okay, we're going anywhere from -6 is our smallest and 12 is our greatest. Okay, so -6 is our smallest, so that means y is greater than or equal to -6 and less than or equal to 12. Okay, so we can finish up our question right there. So I'm going to suggest now that you pause the video and you can go on to try the check on your own. Again, the answers for the check will be found on the Google Classroom. So after you've completed those check questions, you can look at the Google Classroom answer key and check your answers. I will leave the key for this one in the Chapter 6 keys. So even though this is a Chapter 5 concept, I'm going to create a new folder to put the keys for Chapter 6. This one will be found in Chapter 6. Okay, so just a note to look in Chapter 6 for this. So let's take a look at the next page after you've paused the video. Again, you're completing those check questions on your own. That's your practice. Okay. Now, we can find those x and y intercepts using a graph. We can also do this algebraically. So there's a few things that we need. If we want to do this algebraically, we need to know what the equation for our linear function is. So in this example here, they've given us y equals 2x minus 3. Okay, so we can find both our x-axis intercept, okay, and our y-axis intercept, or our x and y intercepts, by doing two things. So when the line crosses the x-axis, that means that y is going to be equal to 0 at that point. Now, without even using this graph to find the actual number, you can see that when the line crosses the graph at the x, the y must be equal to 0. So if we substitute y equals 0 into our equation, we should be able to find the answer from there. So if you look at this example here, they have y equals 2x minus 3. They've substituted 0 in for y. Okay, now we just have to finish the equation and solve for x. So the opposite of subtracting 3 is adding 3. So I would add 3 here. I would also add 3 on the other side. Okay, those would cancel out. I'd be left with 3 equals 2x. Again, to isolate the x by itself, I divide both sides by 2 because the opposite of multiplying by 2 is dividing by 2, and I'm left with x equals 1.5 or 3 over 2. So in this case, they've just put it into a decimal form for us. Okay, so that is where our x-intercept is. If we want to find the y-intercept, again, where the line crosses the y-axis, again, now in this case, my x value would have to be 0. So if I substitute x equals 0 into this equation and solve for y, I can find what my y-intercept is. Okay, so if I take a look at my equation here, y equals 2x minus 3, I substitute 0 in for x, so 2 times 0, which is 0, minus 3, 0 minus 3 is negative 3, so y equals negative 3. Okay, so just a little note here, it says that when the intercepts are integers, it's more efficient to use the intercepts to graph the values rather than table of values. Okay, and we'll get a little bit more into that in the next section. So again, that was just an example there of how we can do that algebraically. So right at the top here, this is very important. Highlight it, star it. Again, if you're making your own notes by hand, this would be something that I would absolutely write down and make a note of. We can use the intercepts of a graph of a linear function. Again, if we want to find the y-intercept, substitute x equals 0. If we want to find the x-intercept, substitute y equals 0. So let's take a look at this next example here. They're going to now find the x and y intercept of this graph and then use that to plot the graph. So to plot those points on the graph and make the line for that equation. So it says here, use the intercepts to sketch the linear function y equals 2x minus 4. Okay, so again, I need to find both the x and y intercept. Those are going to be my 2 points I can use on my graph. And then it does make a note here that sometimes we want to find a third point on the graph in case we made a mistake with one of these. Because remember, a linear function should be a straight line connecting our points. So let's see how this works out. Okay, so we have y equals 2x minus 4. I want to find the y-intercept to start. That means that I'm going to substitute 0 in for my x value. So that means we have y equals 2 times 0, which is 0, minus 4. 0 minus 4 is negative 4. Okay, so when I go to put my point on the graph, my point here is going to be 0 and negative 4, right? Because x is equal to 0 and my y value is negative 4. In order to find my x-intercept, I need to substitute in 0 for y. So 0 equals 2x minus 4. Okay, now I need to solve for x. In order to move that negative 4 to the other side, the opposite of minusing 4 is adding 4. I add 4 to both sides. That gets rid of it here. I'm left with 4 equals 2x. In order to get rid of the multiplying by 2, I divide by 2 because that's the opposite. I do that on both sides, and I end up with x equals 2. So again, when I plot this point, the ordered pair for this is going to be 2 and 0. And then again, they tell you that you should probably choose a third point just to make sure that this is in fact correct. So in this case, they just picked a random value. They said, okay, let's try for x equals 1. So they inputted 1 anytime where there was an x in the equation. So 2 times 1, which is 2, minus 4 is negative 2. So the coordinates for this point are 1 and negative 2. So last thing you would do is you would mark these on your graph and then just use a ruler or some sort of a straight edge to connect the points of that. Okay, so I'm gonna again get you to pause the video now. You can pause the video now, do the check at the top and bottom of the next page. They're going to have you do the x, y intercepts, find a point on the graph, and then create the graph for that. Okay, so I'll get you to pause it, and I'm going to continue on in the lesson. So please make sure you pause right now. Okay, we're going to take a look at the third and final example. So this is matching a graph to a given rate of change and vertical intercept. So we did rate of change actually in the previous lesson. So rate of change, there's another term for this, and if you've taken science or are doing the physics in the science unit right now, rate of change is also called slope. So you may have heard of the slope of a line, same thing. So this one here, this example says, what graph has a rate of change of 1 and a vertical intercept of 8? So let's start with the vertical intercept because that we can just eyeball, we can do it by looking. We look at this graph, okay, oh, y-intercept or vertical intercept is 8. Oh, geez, they both have a vertical intercept of 8. That means that I'm going to have to go on to do my rate of change calculation to figure out which graph fits that description. So just a reminder, my rate of change formula is the change in my dependent variable. Remember, dependent variable is my y value divided by the change in my independent variable. Remember, my independent variable is my x values. Okay, so I'm just going to use the points that they've given us as ordered pairs. So let's start with graph A. All right. So in this case, remember that means that we're going to have distance over time because those are our values here. So let's look at our two y points. The top point is 16 minus the bottom point is 12. Okay. And then for my x values, okay, my second point is 4 and my first point is 1. So again, you can label these as x1, y1, x2, y2. And if it makes it easier for you, you can think of this as y2 minus y1 divided by x2 minus x1. Just another way to think of it. Okay, so if we do our math here, 16 minus 12 is 4. 4 minus 2 is 2. So our rate of change for graph A is 2. Okay, so let's try graph B and see if that one fits the description. So for graph B, again, I have distance over time, which equals, oh, if you can see my top graph here, my y2 point, which is 12, minus my y1 point, which is 10, divided by my x2 point, which is 4, minus my x1 point, which is 2. Okay, so I end up with 2 over 2, which is equal to 1. Ah, graph B. So graph B is the one that fits the description. So again, that is the end of my examples for this lesson. You can stop the lesson now, but before you do, just a reminder to go back and complete the check questions if you haven't already. And then you're going to do the practice questions as well. So you'll be finishing up to and including page 305. Okay, so up to and including page 305. As always, I will be posting the answer key to this so that you can check your own work. And the answer key will be in the chapter 6 answer keys. So please make sure you look for this one in the chapter 6 answer keys. Hope you have a great day. Bye-bye.